Hey everyone, welcome back to my channel, and in this video we are going to be unboxing, installing, and testing the Arctic Liquid Freezer 3 360. And we're going to be testing this in my open air test bench with a Ryzen 9 7900X. I previously did a video testing the Arctic Liquid Freezer 3 420 in my Corsair 7000D with the same CPU. But for this video we're just going to stick with the 360. I am going to rerun those benchmarks in this open air test bench. It's going to be in the next video. And as well, I have another CPU that I'm going to be testing, and that's the Arctic Freezer 360. It's supposed to be a high performance air cooler, so we'll be testing that out as well and see how this compares against these other two AIOs. Now, the reason why I got the 360 is I do plan on downsizing my case. I like the Corsair 7000D. The thing is just too big for what I need. So I do plan on getting something a little smaller, and in that case, the 420 probably will not fit in one of the cases that I'm looking at. So instead, I got the 360. Just gives you a lot more options when choosing a case. So you might want to keep that in mind when you're trying to figure out which AIO you're going to go for, depending on what performance with the CPU that you're looking at. But the 420, there's only a certain number of cases out there that will fit a 420 versus a 360, which is pretty much guaranteed to fit in any sort of ATX case. Well, let's take a look and see what we get inside. Oh wait, no. Before we start, so it tells you on the front, it's not limited to all of these, but this does work for AM4 and AM5 and LGA 1700 and the new Intel LGA 1851. So we have a box of goodies in here. We have some cables. We have mounting hardware, we have thermal paste, and some screws, and a little screwdriver. We'll open this and go through it in more detail after we get more of this out. We have the VRM fan that goes on top of the water block, and this is something I've seen a lot of questions on. The outside here, this is not the fan. This is just a mount and cover. You have to look inside if we can get in there and have it. I don't know if it's actually going to focus on here, but there's a little tiny fan inside. That's the VRM fan. So don't expect this to spin. This does not spin. The VRM fan is inside this housing. And then we have here. We have the LGA 1700, and I'm assuming, yeah, so LGA 1700, LGA 1851 contact plate. This replaces the one that's on your motherboard. There's been issues with that bending, so they actually give you a contact plate that applies a consistent pressure across the entire CPU and does not allow for bending. And that's the last item. Then we actually have the radiator and the water block that makes contact with the CPU. Now, one of the things I really like about what Arctic does, everything's already connected. So if you plan on attaching this to the top of your case, you're all set. If you plan on putting this on the front or the side where this is going to be intake instead of exhaust, you'll have to move the fans over to the other side so that it can push air through the radiator, but it's already set up for top mounting. So all of the cables are already connected, ran, and what I like about this is all of these, all your fans, all the cables are running through this sleeved, the sleeved water hose. and you have one ARGB connector that's going to manage the your VRM cover and the AO with your fans. As well, this is where you get the option. So inside the goodie bag that you get, you can manage the fans, the AIO, and the VRM with just one cable plugged into one fan header on your motherboard, and it'll plug into the water block and plug into one of those cables, or it has a 3-to-1 splitter. So again, it plugs into the same place on the water block, but you have a pump header, a VRM header, and the fan header, so you can control all of them separately. So you have your choice. You can either control everything separately, or you can control everything with just the one cable. And then you got your brackets and mounting hardware for LGA 1700, 1851, AM4, AM5, all that stuff. But the little screwdriver they get in here, that's for the contact plate. So you can use this to remove the existing one on the motherboard and then mount the new one. And you also get some of their MX6 thermal paste, which is some of their higher end thermal paste. So you're pretty much covered as far as everything goes for max performance with your setup, except for LG 1851. Keep an eye out for the new mounting hardware that shifts the water block so that it better aligns with the heat spot on the CPU. And then before we get into it, just to make it easier, before we start mounting it, this VRM housing just mounts right on top, and it connects magnetically to the water block. I'll show it again when we get it all set up. So the AM4, AM5 screws are labeled AMD, whereas the Intel screws are not. So first thing we're going to do is put the plastic risers on. Then we're going to get the two mounting brackets. This is right, this is left. They're labeled with L and R. And they're curved outwards. I prefer a magnetic screwdriver just because if it's easier to hold onto the screws. This one, however, is not magnetic. As we screw these in, they're going to go in snug but not too tight. Once you start feeling resistance, stop. Sometimes the back plate that you're screwing these into is not connected to the motherboard. So, and that's the case when you're taking off the existing mounting hardware on your motherboard, it's just going to fall out. So you'll have to hold it from behind while you mount these on. So now, where this is already in the case, I prefer actually mounting the radiator onto the case first, and then mounting the water block to the CPU or motherboard. So inside, there's more screws. The screws that we're going to use to mount the radiator to the case, there's two different types of screws. I'll show you the difference. These ones with the larger gap in the threads, that's for screwing into the fans. So you can mount the fans if you're mounting this to the front of your case and you had to move the fans around, you would use these to mount the fans to the case. But where it's the radiator that's going to be coming in contact with the case, we're going to be using this one that has a smaller thread and it's rounded on the top, whereas the ones for mounting the fan is flat. So we're going to use those screws plus mounting it to the case. There's also washers. So I'm going to get 4 of these ready because I'm going to do different corners first. And that's going to hold it securely in place. And then from there, I can do all the rest. So the water hoses are going to be facing the front of your case. And while you're putting this up here, just be careful because you don't want to knock anything around. Make sure all the holes are lined up appropriately so you can access all of them. I'm just going to get one snug. Not too tight because you still want to be able to move these around just in case. And get this other back corner in and snug. And there we go. Once you get those 2 in, it's fine to let go. And then screw everything else in. Then once you get all these in, you can go back and tighten them. And then once you get those 4 in place, you can just go through the whole line and get the rest in. Now that I get these all loosely put in place, I'm going to go through and tighten them snug, but not tight. The radiator is made out of aluminum, so it is very easy to strip. So be very careful. All right, now let's mount the water block. So here's where you need to decide which one you want to go with. Are you going to do the single cable or the 3-in-1? So for me, using the 3-in-1, I can control each one of the fans and pumps independently, so I can test noise level and things like that based on fan speed. The first thing we need to do is let's see if we get there. We need to plug this in to the water pump, the water block. So it's going to go into this larger gap. And once that part is securely in place, you can see where they have the ARGB. It's caught going over here. The rest of these cables are going to follow, and they're going to tuck down and around. And there, once those are in place, we're going to remove the plastic. Actually, we're going to save the plastic on there. We're going to remove this plastic last, and that's where the VRM is going to mount. We're going to remove this plastic here off the bottom of the water block. Make sure you take this off. It's a 50-50 shot with me. Am I going to remove it or not? You'll know if you haven't removed it because you're going to have ridiculously high temperatures. So once we get that removed, we're also going to go and grab our little thing of, where is it? MX6. And we're going to put just a little pea-sized amount right here. So the pressure from screwing down the water block will push that around, and it'll cover the entire CPU or the heat spreader. This is going to mount with the water tubes facing downwards like this. The biggest problem people have generally mounting this is they have like these little leaf springs. That's what causes tension as you screw these into those brackets. So apply a consistent pressure as you're screwing it in. If it's not taking, that just means these are not lined up correctly. So just move them around a little bit until they're lined up, but don't push too hard. A consistent pressure is all you need. You don't want the screwdriver slipping off and breaking your motherboard. So I like to line up one of them first and then just lightly thread it in. So we got the one right there, and it's mounted because it's not moving. And then just feel around. That one feels like it's in place and not moving. And I'll just apply consistent pressure there. No. And there. So that is actually easier. I don't know if they changed it or not, but that was easier than when I mounted the 420. Then I'm just going to tighten each side a little bit at the time, so that way we apply a consistent pressure across the motherboard and CPU. Then we're just going to keep on tightening it until it doesn't move anymore. So there we go, nice and snug. Nice and snug. So if you're just using the one cable, you can insert that into your CPU fan header, and it's going to control everything. Where we have 3 different ones, there is going to be 3 different headers here that we're going to use. And it's all labeled. So we got the pump. Is that focusing? Yeah, we got pump. VRM is just going to go into a random 4-pin fan header. You can pick whichever one you want. But we're going to have this fan is going to plug into your CPU fan header, and you control that with the CPU fan curve. Pump is going to have its own one, and it's going to control it with the pump fan curve. And like I said, VRM is just going to be any header that is available. So you can see on this MSI motherboard, we have the CPU, come on, focus, CPU right there. And that is what we're going to use the fan on. Then the next one, all right, focus, the next one beside it, you can see it says pump fan 1. So that is where the pump is going to go. And then since we have an extra fan header right beside everything, if it can focus, see it just says sysfan, that's where we're going to put the VRM. And then all you have left to do is ARGB. And that is going to be right here. It's going to be a 2-pin with the space. Focus, come on. It's going to say right beside it JA RGB, and it's going to have a 2-pin with a space and another pin, and that's going to look just like that. Okay, and then once all that is hooked up, we're going to take this off, and then this VRM fan just going to slide right on and connect with, it's all connected, and then you can take there. Now let's fire it up and see what it looks like. All right, the moment of truth. You can hear the water. I don't know if it's getting picked up on my camera, but I can hear the water flowing through the radiator and through the tubes. Like I was saying, as you can tell, the top blade is not spinning because that's not a fan. The fan is inside. All right, so let's get to some testing. So after running Cinebench R23 for a little while, we end up with a CPU temperature of 88.1 with a hotspot on die 1 of 89 degrees. And the reason for the higher temperature on die 1 versus die 2 is that it's just operating at a higher clock speed. So we're hitting an average of 5.25 gigahertz on die 1. Whereas with die 2, we're hitting just a little over 5 gigahertz. So one of the things that I've noticed about the AM5 CPUs is that they are notoriously harder to cool than AM4. And what I've read online, there's a couple of reasons why it is harder to cool. One, they were saying that the IHS on the CPUs is thicker, just so that it can meet the same specs for coolers as AM4. And then again, when you're using AM4 or AM5, the hardware is the same. So it's placing the cooler at the exact same location on an AM4 as an AM5 motherboard, so that it's not positioned the same along the CPU. And another thing I've read was that the cores on the CPU are further south on the chip than on AM4, so you have a little bit of a misalignment possibly between the water block or whatever heatsink on the air cooler is going to be in a different spot on AM5 than AM4, so it's going to have a little bit more of trouble cooling. And what kind of backs this up as well is based on what Arctic has said with their LGA 1851 it's like for the LGA 1851 motherboards or CPUs, in that they're coming out with new brackets, because the existing ones they have right now can be used on LGA 1700 or LGA 1851, but they're noticing that the hotspot on the LGA 1851 is in a different location, so there's new brackets to move the contact plate so that it better aligns with those hotspots on the CPU. And I'm wondering if we have the same issue going on with AM5. So with that in mind, we are still below any sort of thermal throttle temperature that might arise with the CPU. I think it's 95 degrees with these CPUs, and we're hitting 88.1. So we are quite a ways off from that. And then just to compare VRM, the VRM fan, and see what difference it makes with having it or not having it on. Now over here on the left, that is with the VRM fan on, and on the right is with the VRM fan off. And there is a couple areas where the temperature did go up a bit. So looking at DDR5 slot 1, it is about a degree cooler with the VRM fan on versus the VRM fan off. And on the second slot, it is about 0.8 degrees cooler with the VRM fan on. So we are seeing a little bit of improvement there, but not a whole lot. Then looking up here. So this is the VRM line, and it went up a half a degree, not very much. Where it did see a noticeable improvement is the MOSFETs. It went down. It's at 89 degrees with the VRM fan on, which is 3.5 degrees cooler than with the VRM fan off. So we do notice a little bit of an improvement there. So, and then whatever this T15 is, it looks like it's the same sensor as the MOSFET, because we got the same temperature here. It doesn't say what it is when I hovered over it. But those are like the biggest difference. Again, VRM fan barely, or the VRM's barely any change, half a degree. We have system sensor here is a half degree, not very much of a difference. So overall, in a couple instances, the VRM fan did make a difference in temperature. Now, as far as gaming goes, we are testing out in a couple different games. On Dragon Age VEILGUARD, we're actually seeing quite a high CPU utilization at a little over 50%, and we're pulling in anywhere from 150 to 160 watts. So that's quite high CPU utilization, and that's also translating into kind of a high CPU temperature. It's hovering around 75 degrees, and we're maxing out at about 76 degrees. So in high demanding games, you are going to get a little bit higher of a temperature, but it's still well below the max core load that we saw on Cinebench R23. And it's still well below any sort of thermal throttle temperature. Now moving on to Hogwarts Legacy, we are seeing a noticeable improvement. The utilization dropped down to the high 20s with a power draw of about 125.
and that's then giving us a temperature of 59 degrees at the max that I've seen. So in lower demanding games, and I wouldn't want to say this is a lower demanding across the board. There's going to be a lot of other games out there that are much less demanding, but for a newer title, this is kind of lower demanding and still getting pretty good temperatures.